Good morning, dear students. My name is Ferhan Mazher and today is 5th May 2021. Right now we are studying the subject of physics. This is O-levels physics. Physics 5054 is the code. Today we have set our hearts to solve a paper 1. Today we are going to solve a very old paper, October-November 2004. And it's an MCQ paper. The time allowed is 1 hour. There will be 40 MCQs and you have to attempt all of them. So let's start this paper. So here we go. This is October, November 2004. So let's start. The diagram shows part of a vernier scale. What is the correct reading? You see, this is the main scale. This is main scale. This is the vernier scale. The methodology is we check the vernier scale 0, how much it has passed on the main scale. So this is 30, this is 35, 31, 32, 33. So it has crossed 33. So in your rough work, note down 33 point. And then I will check a line on the vernier scale which coincides with a line on the main scale. So see, this 5th line is exactly coinciding with the line on the main scale. So it will be 33.5. So B is the choice. Question number 1, B will be the right choice. Let me type it. So B is the right choice. So hopefully you have understood or we have taken the reading. So the next question coming up on your screen. The diagram shows a parachutist in 4 positions after she jumps from a high balloon. At which position? After she jumps from a high balloon, at which position does she have terminal velocity? Whenever you have the terminal velocity, your acceleration will be 0. The resultant force acting on you should be 0. So if you look at the diagrams carefully, where the acceleration is 0, C part. This is not accelerating. His parachute is open and he's not accelerating. Not accelerating means he's moving with a constant velocity. When an object moves with a constant velocity, it means it's moving with the terminal velocity when it's falling. So C is the right choice. Question number 2, C is the right choice. Okay, so now we have the question number 3. A particle P is moving in a horizontal circle about O. It moves at constant speed V. Which statement is true? So when you are moving in a circular path, your acceleration is towards the center of the circle. Resultant force is always directed towards the center of the circle. Your motion is along this tangent. And a force of constant size is acting in the direction of the V. That's wrong. A force of constant size is acting towards O. That's right answer. That is right. The force on the P varies in size as it moves around the circle. That is not true because the body is moving with the constant speed. There are no forces acting on P. That is also wrong. So B is the choice. Trolley X and trolley Y are joined by a stretched spring. Trolley X has twice the mass of trolley Y. Look at here carefully. Look at the trolley Y. Look at the trolley X. Its mass is double. Its mass of the X is double. For example, if it's 8 kg, this will be 16 kg. When the trolleys are released, the acceleration of the X is 2 meters per second square to the right. What is the initial acceleration of the trolley Y to the left? You see the force acting on both the trolleys is due to this spring. So the force acting on both of them is same. The mass of the X is double, the mass of Y is half the mass of the X. Acceleration produced is inversely proportional to the mass of the object. If the force is same, the acceleration produced in the y will be inversely proportional to its mass. So its mass is half of the x. So its acceleration, because acceleration is inversely proportional to the mass, so the acceleration produced will be double. So the acceleration produced in the y will be 4 meter per second square. D should be the choice. Question number 4, D is the right choice, sir. Okay. The wheel of the moving car is driven by the engine. The car is accelerating in the direction shown. In which direction does the friction force acts on the wheel? You can see here the direction of the acceleration of the car is towards the left. So the car is going towards the left. So this wheel will be rotating in in anti-clockwise manner. So when the wheel is rotating like this, it's rotating like this. You can understand this. The wheel is rotating like this. So the friction between the wheel and the road will be in the direction of the D. It's a very, very important concept because the wheel is rotating anti-clockwise. So the friction between the wheel and the surface of the road, that will be towards left, along the direction of the motion of the car. So D will be the answer. Question number 5, D is the right answer. Direction of the friction will be D. A stone is weighed using a Newton meter, spring balance, and a pair of scales, pan balance. You know, this Newton meter will be telling you the weight, and the pan balance will be giving you the mass. So if you go, this experiment is repeated on the moon. So you went to moon and you do the same experiment there. So on the moon, you know, the G value will be different. So the Newton meter, which gives you the weight, its value will be different, but the pan balance, that gives you the mass. So its value will be same. Are the readings for each balance the same or different when taken on Earth and on the moon? The reading on the Newton meter, that will be different, but the reading on the scales, pan balance, that will be same because they tell you the mass. Different, same. B is the choice. Question number 6, B is the right choice. Four blocks, each made from a different material. Blocks, each made from a different material, are placed on scales and balanced as shown in the diagram below. In which diagram does the block have the greatest density? So in each option, the mass is given, the volume is given. You can find the density of each option. In each option, you can find the density. The formula for the density will be mass divided by the volume. And very easily you can find the density and then you can compare that. Let's check. I have done this on a paper. Let me show you my work. Okay. So here we go. So question number 7, density of the option A will be its mass divided by its volume. That will be 200 divided by 100. That will be 2 grams per centimeter cube. Density of the B will be 250 divided by 200. That will be 1.25 grams per centimeter cube. Density of the C will be 300 divided by 300. Its mass is 300 grams. Its volume is 300 centimeter cube. So the density will be 1 gram per centimeter cube. And the density for the D, that will be 350 divided by 400, 0.875 grams per centimeter cube. So where we have the greatest density, that is option A, I think. Question number 7, A will be the right option. It has the greatest density, that's 2 grams per centimeter cube. Hopefully you have understood, a very easy and straightforward question. So A is the choice, sir. Hopefully you have understood how we have done this. A load is to be moved using a wheelbarrow. The total mass of the load and the wheelbarrow is 60 kg. The gravitational field strength is 10 Newton per kg. What is the size of the force F needed just to lift the loaded wheelbarrow? So here is an example of the principle of moments. This is the pivot. So the load of the wheelbarrow and the load in its center of gravity will be here. Here their weight is acting, and that is 60 kg. I can convert this into weight. That will be W is equals to mg, 60 multiplied 10. That will be 600 Newton. And the distance from the pivot is 70 centimeter. You applied the force here in the upward direction, and its distance from the pivot is 70 plus 50. That will be 120 centimeter. And you can apply the principle of moment that says the clockwise moment is equal to the anti-clockwise moment. The weight here is trying to produce a clockwise moment. The force you applied here, that is trying to produce the anti-clockwise moment. So they both are balanced by each other. Let me show you my work, and then we will see. So here we go. The clockwise moment is equal to the anti-clockwise moment. Weight multiplied distance 1 equals to force multiplied distance 2. So 60 multiplied 10, because I converted the mass into the weight, that 60 multiplied 10, W equals to mg. Multiply 70 equals to F into 120. So F will be equals to 60 multiplied 10 multiplied 70 divided by 120. And the final answer F will be 350 Newton. 350 Newton. I hope you have understood this question. So let's check. 350 Newton. Oh, A is the choice. So question number 8, A is the right choice. A girl uses paper clips to balance a toy bird on her finger as shown. So here we have a toy bird. Here is the point of support or pivot. And here on the tail, which is below the point of support, they have put some paper clips. What is the effect of the paper clips? We put paper clips on the tail so to bring the center of mass below the point of support. If the center of the mass is below the point of support, then the object is in a stable equilibrium. What is the effect of the paper clip? They have to raise the center of the mass above her finger? No. We have to lower the center of mass. They have to raise the center of mass to her finger? No, they have to lower the center of mass below her finger? Yes. They do not affect the center of mass, but it gives the wind. That's wrong. C is the right choice. We have put the paper clip so the center of the mass comes lower, and it should come below the point of support. Then the thing will be very, very stiff. If you disturb this bird, it's a toy bird. If you disturb it, it will rock and it will not fall. You must have seen these birds. Okay, so question number 9, C is the right choice, sir. Let's move to the next part. Okay. It says that a spring extends by 4 centimeters when 10 Newton is suspended from it. 2 of these springs are used as shown to carry a 30 Newton load. What is the extension of each spring? So here he gave you the information. When there is a 10 Newton force on a single spring, the extension produces 4 centimeters. Now you have 2 springs attached parallel to each other, and you have put a load of 30 Newton here. You see this load, because they are parallel to each other, so this load will be equally divided on 2 springs. So each spring is only experiencing 15 Newton. So let me find out that if a 15 Newton load is hung with the spring, how much should be the extension? We can use the Hooke's law. And let me show you. I've done this. Okay. According to the Hooke's law, load and extension. I'm using the method of proportionality. If when 10 Newton load is hung, 4 centimeter is the extension. My question is, if I have 15 Newton load, how much will be the extension? So 10 divided by 15 equals to 4 by x. Cross multiply 10x equals to 4 into 15. X will be equal to 4 into 15 divided by 10. 4 into 15 is 60. 60 divided by 10 is 6 centimeter. So the extension produced in each spring will be 6 centimeter because both of them are parallel. So there will be a 6 centimeter extension. So let's check what's the marking scheme has to say. Sorry, marking scheme. Okay, so 6 centimeter. So we think that is B choice. We think is B choice. This is question number 10. B is the right choice. Hydroelectric, tidal, and fossil fuels are 3 sources of energy. Which of these are renewable energy source? Hydroelectric is renewable, so yes. Tidal is renewable, so we will say yes. Fossil fuels, no, it's non-renewable energy source, so no. So D is the right choice. Very easily I can predict that D is the right choice. Question number 11, D is the right choice. The diagram shows the energy transfer through a machine. So we have input energy, then we have machine. So a machine will give useful output energy and it will give you the wasted energy. The machine is 50% efficient. When a machine is 50% efficient, it means that the output, 50% of the output will be waste energy and 50% of the output will be useful energy, useful output energy. So if the waste energy is 50% and the useful output energy is also 50%, it means that the useful and the wasted energy, they both are equal to each other. So which statement is correct? The input energy is equal to useful output energy, that's wrong. The useful output energy is equal to the input energy plus the wasted energy, that is wrong. The wasted energy equals to input energy plus the useful output energy, that is wrong. Wasted energy is equals to the wasted energy is equal to the useful output energy, that is right answer. So I think D is the right choice. D is the right choice. Okay. When a 300 Newton force is applied to a box weighing 600 Newton, the box moves 3 meters horizontally in 20 seconds. What is the average power? You can calculate average power if you know the work done. I can calculate the work done and then divide it with the time taken to do that work. That will give you the power. So power is equal to work done divided by time. The work done in this case will be force multiplied distance. Here force is 300 Newton and the distance is the distance moved in the direction of the force, that is 3 meters. So simply multiply 300 Newton with 3 meters, it will give you the work done, and then divide it with the time, that's 20 seconds, that will give you the power. I have done this on a paper, let me show you how I did this numerical. So you can see here question number 13, power is equals to work divided by time. The work is force multiplied distance divided by time. Force is 300 Newton multiplied 3 divided by 20. So your final answer will be 45 watt. 45 watt. Question number 13, 45 watt. Question number 13, 45 watt. Check the mark. Check. 45 watt. Yeah. So question number 13, A is the right choice. Which would be the least likely to sink into the soft ground? Remember, what's the wording? Least likely. Who has the slimmest chance to sink in the ground? Which will have the least pressure on the ground? A loaded lorry with 4 wheels, a loaded lorry with 6 wheels, an empty lorry with 4 wheels, an empty lorry with 6 wheels. So the least chance of sinking, that lorry which is empty and its contact area with the ground is larger, so the pressure will reduce. So I think an empty lorry with 6 wheels is the best. Least likely to sink. Remember this word. And this same story can come with a question, most likely to sink. See, then it will be loaded lorry with 4 wheels. But right now, the statement which they give, according to that, the right answer. Question number 14. Question number 14, D is the right answer. Yes, sir. Diagram 1 shows some air trapped in a cylinder. Diagram 2 shows the same air after the piston has been pushed in slowly. The air in the diagram 1 is at atmospheric pressure PA. What is the pressure of the air in the diagram number 2? So I know the pressure here, and I know the volume here. I know the length. Okay. So I know the length here. What is the pressure here? You know, I know the cross-sectional area in both the cases is same thing. You know, the volume of the gas is equals to the cross-sectional area multiplied the length of the air column. So because here they have pushed the piston in slowly, so the temperature will not change. So I can apply the formula P1 V1 equals to P2 P2. And then I can find out the P2 value. Let me show you. I've done this calculation. Okay, so here we go. So P1 V1 equals to P2 V2. P1, the volume, that is cross-sectional area multiply the length of the air column, equals to P2 volume 2, that is also cross-sectional area multiply the length of the air column. In both cases, the cross-sectional area is same. So A will be cancelled with the A. So now you have PA multiply L1 equals to P2 multiply L2. PA multiply L1 is 10. And P2 I want to find out, and the L2 is 6. So P2 will be equals to 10 divided by 6 multiply PA. 10 divided by 6 multiply PA. So let's check the marks. I'm saying marking, that's the question. 10 divided by 6 PA. C is the right choice. Question number 15. C is the right choice. A student has 3 sealed plastic bags. One bag is full of gas, one of liquid, and one of solid. The student squeezes each bag to see if it changes shape and warms each bag to see if it expands. Which bag contains gas? So whatever bag will have the gas, when you try to squeeze it, it will be squeezed easily. And when you will heat it, because it has gas and the gas expands most, so it will expand most. The one that changes shape easily and expands the least when heated, no. The one that changes shape easily and expands the most when heated, yes. The one, this is the answer. The one that is fixed in shape, that cannot be because the gas does not have a fixed shape. The one that is fixed in shape is also not possible. So B is the right answer. Question number 16, B is the right answer. The diagram shows the cross section through a rainwater puddle formed in a shallow hole in a road surface. Over a period of time, air temperature, wind speed, and wind direction remain constant. Most of the factors are constant. What happens to the rate of evaporation of the water from the puddle? Try to understand. Can you look at this cross-section area? Right now, the surface area of the puddle is very large. Because the surface area of the puddle is very large at the start, and so the rate of evaporation depends upon the surface area. So the rate of evaporation will be fast. But as the evaporation will happen after some time, this level of the water will go down. When the level of the water will go down, as you go down, the surface area of the water will become smaller and smaller. So when the surface area will become smaller, the rate of evaporation will also become smaller. You see, all the other factors, they are constant. So the one factor which is changing, that is the surface area of the liquid. As the level of the water in the puddle will go down, the surface area of the water will become smaller and smaller. So the rate of evaporation should decrease. It decreases because the surface area decreases. Yes, this is the choice. It increases, that's wrong. It increases, that's wrong. It remains constant, that is also wrong. So A is the choice, sir. Question number 17, A is the choice. Question number 18 is showing up on the screen. It says, a new liquid is tested to decide whether it is suitable for use in a liquid in glass thermometer. It is found that the liquid does not expand uniformly with the temperature. It's not expanding uniformly with the temperature. So when you will make a thermometer with this, and the scale will be not linear. What will be the effect of this on the scale of the thermometer? It has a short range. No, it is not linear. Yes, this is the answer. The markings are too close together. We don't know. The markings are too far apart. We cannot say that. So B is the right choice. The thermometer will be no more linear. The fillings for a hole in a tooth should be made from a material that expands more than the hole in the tooth. So the filling and the tooth, they both should have the same expansion, same contraction. Expands by the same amount as the hole in the tooth. That is the right answer, sir. Expands less than the hole in the tooth. This will happen. The teeth and the filling, they will separate from each other. Does not expand when heated. No, that this should not happen. So question number 19, B is the right answer. Heat energy supplied at the same rate, 200 grams of paraffin and 200 grams of water in similar containers. Why does the temperature of the paraffin rise more quickly? You know, the temperature rise depends upon the amount of heat, the mass, and it also depends upon the specific heat capacity. If everything is same between the paraffin and the water, but the rise in the temperature in the paraffin is more quickly, so it means that the specific heat capacity of the paraffin is lower as compared to water. So the paraffin has a larger specific heat capacity than water. That's wrong. The paraffin has a smaller specific heat capacity than water. Yes. That's why its temperature is rising more quickly. The paraffin is less dense than water. No, I don't know. The paraffin is more dense than water. We cannot say that according to the given data. So question number 20, B is the right choice. Okay. The teacher has a large tank of water in which he wants to set up a convection current. So which of the following arrangements would do this? If you want to create convection currents, there could be two methods. You can do it by heating and you can do it by cooling. If you want to do it by heating, then you heat from the bottom. You heat from the X. If you are doing it with the heating. If you want to create the convection currents with the help of cooling, then the cooling should be done from the top. It should be done from the Y or it should be done from the Z. So convection currents can be produced by cooling or it can be produced by heating. If you want to do it by heating, then heat from the X. If you want to do it by cooling, then cool it from the Y. Which of the following arrangement would do this? Cooling at the X, that's wrong. Cooling at the Y, yeah, that's right. Heating at the Y, that's wrong. Heating at the Z. We do not heat from the top. Okay. Do cooling from the top. And the heating is done from the bottom. You see? So cooling at the Y. B is the right choice. Question number 21B is the right choice. Okay. The diagram shows a graph of wave motion. Which quantities are shown by the distance P and the Q? So here you have the displacement. Try to understand this numerical. This graph, there you have the displacement. And here on the x-axis you have time. And a wave kind of thing is shown here. This is basically a graph for a wave, displacement time graph. This P is the amplitude. And this represents time period. This represents time period. So P is the amplitude and the Q is the time period. So A is the choice. Have a good look. A is no doubt the answer. Question number 20. A is the right answer, sir. Remember one thing. If here I have distance, instead of time, I have distance. If here I have distance, if I have distance here, then this thing will be wavelength. This Q will be wavelength. But now, right now, it's time. So this Q represents the time period. Hopefully you have understood. Okay. He says, which diagram correctly shows water waves traveling through deep water to shallow water? You see, try to understand. When the water waves will enter from deep water into shallow water, their speed will decrease. When the speed decreases, the wavelength decreases. It means that the wavefront should come close to each other. So B cannot be answered, then the D cannot be the answer. They're wrong. Totally. Directly, they're wrong. Why? The wavefronts have become far away from each other when the wave enter into the shallow water. When the water wave will enter into the shallow water, the speed will decrease, the wavelength will decrease, the wavefront should come close to each other. So B and D, they are wrong. Out. They are out. Okay, now A and C. You see, when the water waves, they enter into the shallow water, their speed decreases. When their speed decreases, they bend towards normal. They bend towards normal. So if you have your hard copy with you, if you draw normal here, draw normal at this point, you will observe this wave was going in this direction and it has bended towards normal. If you draw normal here, you will see that this is the original direction and it has bended away from the normal. When the water waves, they enter from the deep water into the shallow water, their velocity decreases, their wavelength decreases, and they bend towards normal. They bend towards normal. So A should be the answer. You see, rejecting B and D is very simple, but choosing one of them, A or C, That's little tricky. So if you draw normal, then you will easily understand. And you should know that when the water waves enter from deep water into shallow water, their speed decreases, their wavelength decreases, and they bend towards the normal. Question number 23, A is the right choice, sir. A pin is placed in front of and to the right of a plane mirror as shown. Where is the image of the pin? Okay. So here is the observer, here is that object. So methodology is very simple. This is the mirror up till here. Just prolong this line and make it dotted. Okay. Because originally there is no mirror there. Join this pin with the mirror by 90-degree angle. Okay. Prolong it behind the mirror. And then this reflected ray, prolong this behind the mirror. Where those two lines will intersect, there the image will be seen by this observer. So hopefully that will be on the C. I have done this also on the paper. Let me show you my work. So here you can see I have drawn this reflected ray, prolong it behind, make a dotted line here. From the pin, start a line which makes 90-degree angle with that prolonged mirror, and just take it behind the mirror. Where these two red lines intersect, there the eye will be watching. The eye will be able to see an image. So at position C. So question number 24, C is the right choice. Then we an object is placed in front of a diverging lens as shown on the scale diagram. The principal focus F is marked on each side of the lens. At which position will the image be formed? So here a diverging lens, a concave lens is shown. So how you locate the image? Very simple. We use two rays. One start from the head of the object, comes here, and it moves parallel to the principal axis. When it's here, the lens, then I join this F with this point, and from here, this light ray diverge. Another ray which I use is this top of the object, and I pass it through the optical center. It goes undeviated. So where these two lines will be intersecting, there you will see the image. Let me show you. I have drawn this. So you can see I have drawn a red color line starting from the head of the object, moves parallel to the principal axis when it comes inside the mirror, sorry, lens. Then I join this F on the same side. From here, I join a line, this is a dotted line with this point and prolong it. So this red light will come here and diverge. And then I use the second ray which starts from the head of the object and moves through the optical center of the lens. It goes undeviated, goes like this. Where these two rays intersect each other, that will be the top of the image. So image will be formed at the point C. Image will be formed at the point C. Hopefully you have understood at the point. Question number? So that was the question number, I think, that was question number 25. C is the right choice. The diagram shows the spectrum produced when white light is dispersed by a glass prism. What are the numbered visible colors? So remember that code word Roy G. Pill. Roy, red, orange, yellow, Roy G, green, viv, blue, indigo, violet. Roy, red, orange, yellow, green, blue. So I think C is the right choice. Question number 26, C is the right choice. Don't forget this code word, Roy G. Piv. ROYGPIV. That's the order of the colors in the spectrum. So I think, what's the choice? I think C is the right choice. Question number 26, C is the right choice. A bar magnet is broken into three parts, X, Y, and Z. Which diagram shows the poles of the X, Y, and Z? You see, very simple. The bar, if you have a magnet, you break it, and the broken pieces, each of them will be like a magnet. It will have its own north and south. So if this is the north, this will be the south, north, south, north, and south. So I think B will be the answer. Question number 27. I think D will be the right answer, sir. I think D will be the right answer. Yeah, D is right. The potential difference between the ends of a conductor is 12 volt. So I know the voltage. How much electric energy is converted to other form of energy in the conductor when 100 coulomb of charge flows through it? If you remember, the formula for the voltage is energy divided by charge. Energy divided by charge. So energy is question, charge is 100 coulombs, voltage is 12 volts. So apply that formula. Let me show you my answer. I have done this. So let me show you. So, okay. So, you know the voltage. So the voltage is equal to energy divided by charge. 12 volt equals to energy divided by 100 coulombs. So 12 multiplied by 100, that will be 1200 joules. So the energy will be 1200 joules. Very simple and straightforward question. If you know the formula, then I hope that there will be no problem. Okay. Let's move. Next question. B is the right choice, sir. Question number 28. B is the right choice. A wire length 1 meter has a resistance of 2 ohm. When connected to a cell, the current in the wire is 3 ampere. A 2 meter length of the same wire is connected to the same cell. What is the resistance of the wire and the current in it? So you see, when the 1 meter is resistance is 2 ohm, when you double the length, the resistance will also double. So the resistance of the wire should become 4 ohm. And when the resistance will become double of the total resistance, the current coming from the battery, that should become half. So before there was 3 ampere current, now there will be only 1.5 ampere current. So I think C is the best. The resistance will become double, the current coming from the battery will become half, because when the resistance doubles, the current half. So I think C is the right choice. Question number 29, C is the right answer. In the circuit shown, at which point is the current the smallest. You see the current coming from here, the current comes from the battery, and here the current will be divided in two branches. Because here in this branch, the resistance is 6, and here the resistance is 4. So smaller amount of current will flow from here because it has high resistance. Here, larger amount of current will flow. Here, both the currents will join again, and through the 10 ohm, all the current will pass. So the smallest current can only be possible at B. Sorry, B for baby. So the smaller current is passing through the B. Because here the current is splitted, a fraction of the current is going from here, and this branch has the more resistance as compared to the other branch. So that's question number 30. So B is the right choice. Okay, now an electric engineer connects a diode to a radio so that if the battery is connected the right way round, the radio works. If the battery is connected in the wrong way, there is no current. So which diagram is the correct? The conventional current will go into the positive, so the arrow of the diode should also be along this. This is the right choice. You see, this is wrong because according to our convection currents, from here the current will be coming out because into the negative. The current is going, because the convection current is coming like this and going back from here. So the radio will be never on. So C is also wrong, D is also wrong. You see, and the best way to do is, I think A, question number 31, A is the right choice. First of all, let me read, then I will show you all the options. Which circuit shows how the heater in an electric iron and a fuse should be connected to a main electric supply? The fuse should be connected in the live wires, and the earth wire should be connected with the metal casing. So the fuse should be in the live, and the earth wire should be connected with the metal frame of the iron. So I think D is the best option, sir. D is the right answer. Question number 32, D is the right answer. The diagram shows the force is F between two wires carrying current out of the page. The magnetic field close to the wires are also shown. Which diagram is correct? You see, if both the conductors, the direction of the current is same in both of them, they should be attracting each other. The parallel conductors in which the direction of the current is same, they should attract each other. So they should be attracting. Either B or D will be the right answer. They should be attracting each other. B or D can be the answer. So let's apply the right-hand rule for the straight conductor to find out the direction of the magnetic field. You hold the conductor because the current is coming out of the page, out of the screen. So curl the fingers of your right hand. The thumb is in the direction of the current. It's coming out. When I look from here, from my side, it should be anti-clockwise. The magnetic field should be anti-clockwise. So B is the right answer. because in the D, the magnetic field is shown is clockwise, which is wrong. I applied the right hand drift rule for the straight conductor to find out the direction of the circular magnetic field lines around the straight conductor. And the current is coming out of the spring. Dot means that the current is coming out of the spring. So B is the right answer. That was question number 33. B is the right answer. Question number 34 is on your screen. A small coil is connected to a sensitive ammeter. The ammeter needle can move to either side of the zero position. When the magnet is allowed to fall towards the coil, the ammeter needle moves quickly to the right of the zero position. The magnet moves through the coil. How does the ammeter needle move? As the magnet falls away from the coil. When the magnet will fall away from the coil, the direction of the deflection in the ammeter will be opposite. So it does not move. No, it gives a steady reading to the right. No, it moves quickly to the left of the zero position and then returns to zero. Yes, that's the right answer. It moves quickly to the right of the zero position and then returns to zero. No, C is the right chance. C is the right choice, sir. A cathode ray oscilloscope is connected to an AC generator. A wave is shown on the screen. What is the effect? What is the effect on the trace if the generator speed of rotation is doubled? It's a very famous question. When you double the speed of the generator, the frequency of the display which is showing here, that will double. So the number of waves showing on the display, they should double, and the amplitude of the wave will also double. So I think double. C. Question number 35, C should be the answer. Question number 35, C should be the answer. Okay, here we have. In which circuit will a lamp glow more brightly when less light shines on a light-dependent resistor? So LDR, light-dependent resistor, when there will be less light, the resistance will increase. So if, look at here, if here the resistance light will decrease, R1 will become larger, R2 will remain constant. So the V out on the R2 will be less. So the brightness will be less. Okay. Here on the R1, we have a fixed resistor. On the R2, we have the LDR. When the light will decrease, the resistance of this R2 will increase. When the resistance of R2 will increase, the voltage drop here will increase. And so the lamp will become more bright. Here, no LDR is present. Here, no LDR is present. C and D cannot be the answer. So I think B is the right answer, sir. B is the right answer because when the R2, which is the LDR, when the light shining on it will decrease, its resistance R2 will increase. So the voltage drop here will increase. So the lamp will become more bright. 36, B is the right answer. The diagram shows the design of a cathode ray oscilloscope tube, and the diagram shows the design of a cathode ray oscilloscope tube. There is a constant potential difference across the deflection plates, which increase the deflection of the spot on the screen. Increase the deflection. So the more bending upward or downward is done, decrease the distance from the deflection plates to the screen, it has no effect. Increase the length of the deflection plates. Yes. increase the potential difference between the cathode and the anode? No, it has nothing to do with the deflection. It has to do with the speed of the electron. Increasing the separation of the deflection plates? No. So increasing the length of the deflection plates, if these deflection plates will be longer, the electrons passing from through here, they will spend more time in the electric field, so they will be bended, they will be affected by that electric field more. So I think B is the right answer. The unusual question. B, question number 37, B is the right answer, sir. Okay, so now we have question number 38. When dealing with the radioactive substances, there are possible dangers. Which statement is correct? Beta particles can pass through skin and damage body cells. That is true. Gamma radiation is more dangerous than alpha or beta because it has a longer half-life. That's wrong. Half-life is of the radioactive nucleus, not of the gamma radiation. Materials that emit only alpha particles must be kept in the thick lead containers. Alpha particles penetration is very, very low. So you do not need a thick lead container for alpha particle emitting radioactive source. Radioactive materials are safe to handle after 2 half-lives. That's wrong. So I think A is the best answer, sir. The only right statement is in A. So question number 38, A is the right answer. A nucleus consists of 90 protons and 144 neutrons. After emitting 2 beta particles, followed by an alpha particle, this nucleus has. So it gave out 2 beta particles and 1 alpha particle. So let me show you my answer because we have to do some calculation here. See. So suppose X is the name of that parent nucleus, 9234, and when 2 beta particles will be given out, whenever a beta particle is given out, the proton number increases by 1, the mass number do not change. So because 2 beta particles are given out, so that's why the proton number will be increased by 2 and the mass number will remain unchanged. Then an alpha particle is given out. So when alpha particle is given out, the proton number will decrease by 2 and the mass number will decrease by 4. So the final thing will be this Z 9230. So proton numbers are 90 and neutron numbers are 230 minus 90 and that will be 140. It's a tricky MCQ. So 90 and 140, I hope that you have understood this. And let's check. 90 and 140, 90 protons and 140. So 90 protons and 140 neutrons. C is the choice, sir. Question number 39, C is the right choice. Okay, so here we go. Deuterium H12 and tritium H13 are 2 isotopes of hydrogen. Compared to a deuterium atom, how many protons and neutrons does a tritium atom have? Protons will be same because they are isotopes, so their proton number is also 1. So they will have the same proton number, same. And the neutron number, the tritium will have one more neutron number, one more neutron. So try to understand this sentence. Compared to a deuterium atom, how many protons and neutrons does a tritium atom have? So we are talking about tritium compared to the deuterium. So tritium has same proton number, but one more neutron. So C is the choice, sir. Question number 40, C is the right choice. So by doing this, we have reached the end of this paper. This paper has 40 questions. So my dear students, today we have done, exercise. Today, we have done Super November 2004, Physics 5054, paper 1. And this was an MCQ paper. I hope that this paper will make your concepts more clear. And if this video is helpful to you, don't forget to subscribe to my YouTube channel. Also suggest these videos to your friends and share them in your Facebook and share them in your other social media groups, WhatsApp groups, because this will help me and this gives me energy. So thank you very much for your patience. I hope that this will be a blessing for you. So thank you very much, everybody. Have a good day, and God bless you all. Thank you.